Question 7. Draw the structure of an ether with the formula C5H12O2 that fits the following NMR spectrum. So the HDI of this compound, the hydrogen deficiency index, is 0. So no double bonds, no rings to worry about. You can see from the step curves here and the integration values that are given down here. So roughly 4 and roughly 4, so that means it's a 1-to-1 ratio. If I have 12 protons, that means that this singlet must represent 6 protons, and this singlet must represent 6 protons. So none of the protons are split by anything. So there's only one possibility, like any other kind of problem. There's only one way to put these together. And I guess you could kind of play around with it, but if you think about it, you must have a CH3, you must have a methyl group attached to an oxygen somewhere in the molecule, because if you think about the chemical shift of that methyl, you would say 0.9 plus 2.5 because it's attached directly to an oxygen, which gives you 3.4, and lo and behold, this peak is right around 3.4. Also, for the chemical shift of these 6 protons here, which also must be represented by 2 methyl groups, you can see the chemical shift is right around, I don't know, like just above 1.5, okay? So if we take the 0.9 for our methyl group and we add 0.5 for being beta to an oxygen from an ether, then that would give us 1.4. So that makes sense that we must have a methyl group beta to this oxygen here, because that would give us the appropriate chemical shift. So based on what I've written down so far, the only possibility would be to add a second methoxy group to this carbon. So if I add a second methoxy group here, and I have to have another methyl group because I have 6 protons here and 6 protons here. So therefore I would put another methyl group like that. And you can see that there's symmetry in the molecule. You can see that these 3 protons and these 3 protons are chemically equivalent, and then you can see that this methyl group and this methyl group are chemically equivalent. So there we have it. We figured out the structure of the ether, which actually happens to have 2 ethers. We justified the chemical shift of the de-shielded methyl protons and the chemical shift of the other 2 non-ether methyl groups. So there we go. We figured out the structure of the compound pretty quickly.